screen. How are you guys doing?
All right.
How do you like the new parking structure?
It's amazing.
It's amazing?
I don't have to use my scooter to get here.
You have an electric one, or is it
No,
just
it's
a regular?
big wheel cruiser type scooter.
Oh, okay.
And it's old. It's like a regular small wheel racer scooter.
Uh-huh.
Only it's just got larger wheels and I can fold it.
I see.
I no longer have to get here at 6 o'clock.
Park in the rear of the stadium lot and just ride my way across. Now I just park on the second level and walk downstairs. So much nicer.
Yes. Well, the college actually has that already planned a long time ago. So we are basically using money earmarked for different projects. Many years ago, which is really good because not only does it give you guys the parking structure that you need, but at the same time when the economy is not doing well, it's putting money into local companies. The construction company, the company to provide material for construction, the workers and whatnot. So it's actually a very good thing for the entire region to have money that is kind of scheduled for future projects. Okay, so what we'll do today, let me first log into the website first, and then we'll go from there. Okay. How do you guys like this topic about hardware stuff, transistors, logic gates and stuff like that? Some people might like it, but I think some people may find it kind of a little bit dry and it's all talk and too much theory, right? So what I'm going to do is to change gear a little bit. And use an example, and that's why I wanted this to be really recorded, because I think some people may want to, or have reasons to go over that, once in a while, or just right after the class. I'm just double checking to make sure that I have enough space on my drive. Yep, I got about 17 gigs left, so I got plenty of space left. Yep, go ahead.
We have a midterm this week.
Midterm?
Yeah.
Yeah, I really should be scheduling a midterm, so let's schedule that for next week, because that will give you 1 week's time to prepare for that. So let's schedule that for the 14th. Huh?
Online?
No, it's not going to be online. It's going to be on paper.
And
So
that's all the topics that you talked about, right?
yeah, pretty much all the topic, but since I digress a lot, it does not include the digression. So anything that does not have anything that's written won't be on the test. And that's about 75% of the stuff. Right.
I just kind of wonder because I've been having midterms for the last 2 weeks, and I had a big one yesterday, and my mind is kind of like.
So next week is a good time.
Yeah.
Yeah, it's better than last week or this week.
Because
I understand.
One I had yesterday was dealing with hooking up routers and all that stuff.
So your brain is still routing, right? It's still going to, okay, how do I go this from here to here?
Yeah, but I'm saying I still got another one that I got to do by Monday because I got to hook up 6 routers and stuff, and they're not even in the same town.
Yep. Well, as I said, your brain is still
Do we need a Scantron?
routing. No Scantron, nothing. Everything will be just done on paper, on the pieces of paper that I give you. So you don't need any Scantron. Just take the test itself. Circle the right answer, or write down a short answer. Stuff like that. And you turn in the paper back to me. I grade it. I return the paper back to you. Yep.
Is there going to be a study guide, or should we just look at the notes online?
We can do a little study guide next time, maybe on Tuesday. So we can just kind of go over everything that we have talked about that is already on Moodle. The digression, I remember most of my digression, and most of that is actually recorded, but I don't want to test you guys on the digression because it is not, written, and therefore a little hard to study.
In the last 2 weeks, there hasn't been no homework or quiz, right? In the last 2 weeks, there's been no homework.
No, because I'm, kind of trying to decide what to do next, and I have the schedule for the other future topics too. And because of the digression, we are actually covering a lot of the material that I have to cover, but it's just not written here because I just decided to fast forward and make the material. I talk about the material in the class, but it's not written yet, in the future sections. So you will revisit. We will revisit some of the stuff that we have talked about. Except it'll be more formal by the time we get there. But by the time we get there, most of you will still remember what we talked about over the past few weeks. So I think it's just a little bit different in terms of organization.
What is the test?
Sorry?
Next week?
Yeah, next week, next Thursday, 1 week from today, we will have our exam one. It is open book, open notes, but no electronics. So anything, open book, open notes, but no electronics.
No computer?
No computer, no cell phone, no e-book reader. It'll be all on paper. Old school. Sorry?
So we can print out the topics.
Oh yeah, you can print out anything. You can go to Wikipedia and print out anything that you might find useful. You can study together, come up with your own notes. Anything that's prepared before the class, before the exam, that's either handwritten or printed, you can bring those in.
So all the topics that you're talking about, we can print out?
Absolutely. There's no reason why I want you to memorize everything when it is available on the computer.
So that should be easy midterm.
Maybe.
Sure.
Let us use computer then. Let us use computer.
You cannot use a computer because this is not a computer classroom, so I cannot make sure that everybody can have a computer, and as a result, I cannot let computers be used in this class. Because someone who does not have access to a laptop computer or tablet, would be at a quote-unquote disadvantage. And I don't want some people to have an advantage because they can search for information a lot faster than other people. So to level the playing field, I just want to make everything paper-based.
Suggestion.
Yeah.
Do like one of my teachers did for computer class. He turned around and put it online and let it at an open date, and you can turn around and do it online, and then come back and turn around and do it on a day.
Oh. Yeah, well, for this class, maybe I can arrange it to be taken over at the lab because, the class size has kind of settled, to about, 30 something, close to 40, but not quite as big as what it was. But I think I still like it to be, I still like to have it on paper, okay? Because then you can still look up something if you want to, but you cannot, use Google to search for something, because, that kind of defeats the whole purpose, I think.
So can you turn around and be able to just let us look at it, and then we can go ahead and do our Google if at home and do our notes.
I think I just do it on paper. Paper is
No,
good.
I'm just saying. Can you turn around and give us the questions, and we can turn around and go online and get the answers, and then come back here and we're gonna be taking a paper test,
If I make it online, I have to make sure that the answers cannot be easily Googled, right? Or if you Google, it would take you to the wrong answer. Yep.
I was checking when I was studying in the library that you give us a code that go in a video from Bill Gates email, send us an email. That was
Oh, right. Yes,
there was a link that I click.
Mhm.
They allow us to register and take free classes for coding programs.
Yes.
As a beginning. And I
Yep.
already did, and I'm taking, because you said that's link, right? If that's okay?
Yeah, absolutely.
Academy.gov.
You can definitely do that.
You can put your
Yeah.
email name, and you can choose a program that you want to start. I am a beginner, so I just start as a code
Yep,
PhD program.
definitely. Yeah.
That's okay? Or no?
Yeah, that's okay. I'm not sure, whether everybody got this email because some of you have already configured your student account to use Gmail, and some people may not have set up your email to forward to your Gmail account. So I think some people may not be getting this, but this is what I sent to everybody. The title itself may actually cause the email to be sent to the spam folder because it self claims to be spamming, right? But basically it's a YouTube video clip that was prepared by a bunch of really important people in the computer industry to basically say why programming is important, why everybody should learn something about programming, about the thinking process, about generally speaking what it is, and so on and so forth. It is particularly important to this class because we will have a programming part of this class. We will talk about programming for about 2 or 3 weeks. Okay, we'll do some really kind of superficial kind of programming, but nonetheless, it is your programming and has logic involved. And if you have never done programming before, or if you kind of dread programming because you have heard all kinds of bad things about, it's really hard and stuff like that, just be open-minded. You might find it useful because you can automate certain things that you have to do by hand, normally, especially things that you have to do online. And you might find programming to be useful in, the kind of least expected kind of situations. So that's why I sent everybody, not just in this class, but all my classes, this little link here. So I just thought it might be useful.
What types of programming are we going to be doing?
Huh?
What type of programming are we going to be doing?
We'll just be doing some fun stuff. We'll be using Scratch from MIT. Now, Scratch is a very, okay, I'm digressing already. I'm already stepping away from what I'm supposed to be talking about today. But we will talk about it. So this is just a kind of fast forward or preview of what is coming. Okay, it's just like when you watch a movie, you have previews of 20 different movies that will be coming, right? Except in this class, the preview takes over like 50% of the class time, and the feature presentation is only the other 40%. You guys are not getting it? Okay. Okay, because at some point we have to get to this part here. We have to deal with programming logic, and also talk about programming functions, overview of languages and stuff like that. So those are all programming concepts. For those of you who want to get a little head start, this is how you get a head start. You go to scratch.mit.edu. Everything is being recorded right now, so you don't have to worry about, okay, but I can't remember the website. Well, it's all recorded. If you know how to find my stuff on YouTube, it's all there already. This is programming, but it is visual programming, okay? And this is much more visual than Visual Basic, okay? And the user interface is really simple, really easy to deal with. You just drag and drop blocks to make your programs. And you can click on stuff to make it run, to test your program. And the best part is you can integrate video, audio. You can draw pictures. Okay, you can animate things that you create on the screen. You can make up games. You can see what other people have done with Scratch and get their source code and figure out, oh, so this is how they do this, blah, blah, blah. Yep, go ahead.
Maybe I misunderstand. It sounds like something that that's designed for 5, 6, 7-year-old kids, or like an easy, basic program.
This has nothing to do with age. It has to do with people who find the syntax part of a programming language to be intimidating. Because this has no syntax, okay? It won't let you drop a block where it does not belong, or it cannot belong.
So this is the electronic version of programming for dummies?
It's the easy way to understand programming. It has the basic constructs as any programming language, but to use it, it is very easy to use. You just drag and drop blocks. You still have to understand the basic concepts behind programming and conditional statements, loops, and stuff like that. We'll talk about that. But to make it fun, you can actually integrate your own bitmaps, images, pictures, photos, okay, and make it really fun because you can actually integrate audio stuff as well. Okay, so you can record. You can take a picture of someone. You can record the voice of somebody else and integrate all of those into a game that you're designing. So it's really fun. A lot of students of mine from past classes, from past cisc310 classes, ended up taking programming classes because they just felt oh, this is the kind of stuff I can do with Scratch. I want to see what else I can do with programming. So when we get to that part, it will be fun. Okay.
So you're saying basically you're gonna show us how to get to some of the dummies that get to the code of open source software to be able to do.
It's not
programming.
open source, but you can definitely look up. Okay, for those of you who want to really get a head start and you cannot wait for me to talk about Scratch, YouTube. Okay, YouTube has tons of resources on that already. Just look up MIT Scratch tutorial or just MIT Scratch, and let's see how much stuff we can find. Okay, that's definitely just advertisement. Scratch tutorial, Scratch soccer game, programming with MIT Scratch, Raspberry Pi with MIT Scratch, and so on and so forth. So you can find tons of resources online to talk about how to do programming in Scratch, and I will cover that too. I will actually talk about it in this class, okay? With Scratch. But if you want to get a head start and you're just curious about what Scratch is, that is something that you can look into. Yes, go ahead.
I spent the holidays with my 10-year-old nephew, and he was showing off his Minecraft skills. Is that kind of the same idea? You just drag and drop blocks and that nature and create?
In a way, because in Minecraft they have the redstones where you can use that to build circuits and automate certain things. It is similar in a sense, but it's not identical. My 8-year-old son, was dealing with Scratch before he picked up Minecraft, and he was reading the code from other people. There were a lot of half-baked games on the Scratch website. Basically, people who got a really good idea of how they want the game to go, but they could not finish up the game. Okay, so they put out whatever is half-baked on the website and just said, I could not finish the game, but it's supposed to do da 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 da. Okay, so my son would look into those things and go like, oh, okay, I can look into it, and sometimes he can figure out how to finish up the game, and he will post his finished game on the website so other people can download it, look at the source code, and potentially improve it. Yep.
Yeah, I'm making a reference in just like the most vaguest of sense. Is it similar to the Blender, like?
That's a 3D rendering.
Well, yeah, I know, but like, as you could, after your finished product, you just put it on like the website and whatnot?
Yes.
So like,
yep, it is open source in that way. So when you go to the Scratch website, which is here, it is kind of like YouTube, but for visual programming. In other words, you can just download the software, do your own programming for this class, and after this class you can just delete and uninstall everything. Okay, that's one way to look at it. The other way is to look into here. You have to sign up for an account first. But once you have an account, you can actually download the projects from other people. So not only can you play with those projects, you can also look at the source code of all of those other projects, and then you can understand, oh, so that's how they did this, okay? I can pick a few, we are digressing more and more. Okay, Final Frontier looks like a game. So we'll start with the game because most people just say, okay, I want to play with something. Okay, so this is Final Frontier. This is flash-based, so your computer has to be flash-enabled to do this. Doesn't have any specific instruction, so we'll just go ahead and hit the green flag to get it started. Ah! Shoot. Die. Ah. Okay, so this is all written in using Scratch. Ouch. All right.
I love this class.
Okay, so that's basically the game. But then you can sign in, okay? If you want to understand how they actually wrote this game, you can sign in and then you can download the actual program in Scratch. And were you doing okay so far? In terms of the concepts, okay? So in a way, it's kind of like YouTube. Everybody can upload their projects, their contribution to the website to share with everybody else. But at the same time, it's better than YouTube because it also gives you the tool so that you can create your own projects, or at least you can inspect and kind of analyze, how other people get their projects done. All right. Okay. I can actually see, whether something. I can see that I might need to change the ordering of the topic to talk about this one first because so many of you are now interested. Yep.
The code.org. Website. When you register, they have so many programs for everything.
Okay.
And there is one that I started, a PHP, which is very similar, not same, but the same structure when you code in Visual Basic, the code program.
Okay.
And they just give you step by step, say now you have to type the name,
right,
line 9, in between the codes, and you just start.
Yeah.
I don't know about the other one, it's more advanced, but,
I think the other one is less, serious. It's more, like, well, let's start with a game. Let's start with, putting audio content and visual content into your project. And it doesn't have to be coding either. I mean, you can make it very simple. You can make it very complicated. But this is nonetheless a very good, website. It just has a lot of resources available. But I think it is a lot more serious about, coding. Yep. Go ahead.
I would compare Scratch to Dreamweaver in a way. 'Cause Dreamweaver allows people that don't necessarily know HTML or other web languages to build a website.
Mm-hmm.
So Scratch would be comparable to that.
I would say Scratch takes it even one notch lower in a way and one notch higher in a way. Dreamweaver is a design software, but to use Dreamweaver, you kind of have to take a class because the user interface of Dreamweaver itself is kind of complicated. Even though it's a very capable software, it can do a lot, but to use the tool, you need to know quite a bit about applications already, because the control of the application itself is complicated. Scratch is easier, much easier. But on the other hand, Scratch, teaches programming concepts to a fairly deep level. You can actually use it to do a lot of really advanced type of programming, whereas Dreamweaver gives you all the canned solution, and it doesn't really let you do a lot of coding on your own.
It does if you do like a side by side and you're writing the code.
Yeah,
as
but
you're going.
the code that is generated by Dreamweaver, if you make changes to that, sometimes it will break Dreamweaver. It cannot read back its own code anymore, and you can basically it can break your project if you decide to change its code to in a certain way. In other words, you look at the output of Dreamweaver, you look at it, go like, oh, I can do this a little bit better. Okay, so you went ahead and changed it, and then when you try to bring up the project again inside Dreamweaver, sometimes it cannot pick up what it had, what it had earlier before your modification. Okay, so I can see now that I should probably switch around the topic order just a little bit again. I know some of you do not really like it when I jump around like that, but I think since we have so much momentum, just talking about Scratch, we'll just go ahead and capitalize on that momentum today. You have heard of the term, stopping on a dime and turn around. In this class, it's not even that; it's teleportation. It's like, yeah, we're going this way at full speed, and then we're somewhere else in the universe.
You got the rope sheet?
No, I forgot. Yeah, my ADD is talking to me, so
We're all good.
we're all good. Okay, but everything is recorded. It is still content that you need to know. I'm just switching the order because sometimes if I keep talking about logic, gates, transistors, and keep yakking about it, you guys get saturated by that stuff. It's like, no, I cannot take it anymore. If I switch to programming just a little bit, I think it'll give you enough breathing room to kind of let that other stuff sit around a little bit. But at the same time, guess what? You can use Scratch to implement logic gates. So they're all related. I know some of you do not like it, but since it's all recorded, you can watch it again, and I'll write about it too. I'll just go back and backfill the content. All right, so let's go ahead and begin with the Scratch website. The first thing you want to do is to download the tool. I'm not sure whether they are up for the new version already because they have a new version available. Let's see here. Do they have download this project? Let's go back to home. Okay, so they're still using the older version. Version 2.0 is in beta stage right now, so for those of you who are adventurous, you can go play around with version 2.0. But when you go to the website, it is still on version 1.4, which is all that we need for this class. So we'll go ahead and just go there. So for the first thing you want to do if you want to use Scratch is to click Download Scratch. Okay. And it has one version for every major platform. For most of you, it's probably just going to be the Windows version. But if you have a Mac, OS 10, computer, you can download the version for the Mac also. I have it already installed in Debian Linux, so it's already done on my computer. I don't have to install anything to make use of it.
Is it scratch.com or what?
It is The website is scratch.mit.edu. That's the main site.
Because I downloaded something and they brought me up on Scratch DJ.
No, it's scratch.mit.edu. Okay, make sure it's ending up with edu. All right.
Oh, okay.
So when you run the program, this is what it looks like. Okay, because I got it already installed. This is the user interface. You don't see a gazillion toolbar and buttons and whatnot. It's a fairly, I would say, it's a pretty clean interface, even though it allows you to do programming. Okay, so let me just kind of talk about the various parts of this program. This part here is kind of like your toolbox. Okay, so the left-hand side is your toolbox. The toolbox is organized into 8 different drawers. And you can only look at one drawer at a time. There's one drawer for all the motion-related stuff. There's a drawer for all the appearance kind of stuff. One drawer for all the sound, audio-related stuff. A drawer for pens. Okay, we'll talk about what a pen is. A drawer for control, and this is by far the most important part when it comes to programming. Okay, so the yellow tab or the yellow drawer is the most important one. We'll talk about that. There's one for sensing, okay, which is really useful when you want to write a game of sorts. There's one for operators. They're all the essential stuff, kind of boring stuff, but they're the really, really important building blocks of a program. And there's one block for variables, which looks really empty at this point, but depending on the complexity of your program, this can get very large and long at some point. Okay. So these are the 8 drawers, okay? They store the tools and the material that you need to write a program in Scratch. We'll kind of skip this part for now, okay? We'll go to this part here. This is called the stage, okay? The background of this entire thing is called the stage. And then each item on the stage, like this guy here, the little cat, is called a sprite, okay? So instead of looking at the cat as quote-unquote a sprite, which is a term from the Commodore 64 days, okay, which is a long time ago, look at it as an actor, okay? So look at this as an actor on the stage, okay? So your job is to say, well, I want this actor to do certain things, okay? I want to add more actors to do other things, to make a play, make a drama, to make a program if you want, okay? So are there any questions at this point about the left-hand side, which are basically your toolboxes and material stuff, and the right-hand side, this box here, which is called the stage, and everything is going to happen on the stage. What you are doing is you're writing scripts or programs to specify how things should work on the stage. Question? No? Okay. All right. This little part here, okay, allows you to specify new sprites or to create new sprites. Sprites are the actors, okay? In other words, you can tell an actor, what to do, and you can also change the appearance. Let's go back to the middle part. The middle part here is basically a place where you can specify details. If you have the sprite highlighted, then everything here is related to that particular sprite. If you click the stage, then everything here is related to the stage. You can create new sprites and click the new sprite, and then everything here will be related to the new sprite. So you can look at this middle part here as the detail window. Okay, what are the things that you are constructing? Okay, it can be images, can be audio files, can be the logic, but the details of something, of the character that you are designing, will appear in the middle part. Do we have questions at this point? Leftmost part, tools and material. Middle part is kind of like your workbench, the work area. Yep.
So is this like basically you doing video editing?
In a way, it is similar, but it's not the same. Because I can understand why you say that. So basically, the left-hand side is equivalent to the toolbar, of a regular application, because that's where you can access all the tools and all the material that you need to make something. The middle portion is your workbench, okay? This is where you lay out all the stuff and say, okay, this has to go here, this has to go here. Oh, I don't like this image, I have to change it. That's the middle area. And then the area on the right-hand side is basically the stage. This is where you test your program. This is where you run the program and see, how well it works. Are we doing okay so far?
Okay, so it's not like video editing, because I know.
No, this is not video editing. This is actually for programming.
Okay, because I always wonder, because I mean, it's like if you're using Vegas and Pinnacle and all that stuff, they have certain things. You have your, besides your rendering, you have your, what you can turn around and do, the video change the dynamics and stuff like that. And
No, this is not a video editing software. It is a little bit beyond that. Okay, in a way, it is actually beyond that, because you're not changing content. You can use it to create content. You can make the sprites behave in a certain way, in a programmed way. Okay, so we'll go ahead and take a look at what kind of stuff we can do. Go ahead.
You described the left side as what?
I cannot remember what I said.
Oh, the middle part, you said like a workbench and tools. You described the left side as what?
The left side is your toolbox.
You said like a tool.
Kind of like your, the Craftsman, 7-drawer rolling tool cart thing. Okay. All right. So let's look at all the little things that we can do, and we'll start with something that's relatively simple and and at the same time kind of fun to do. So we'll click the sprite first. Okay. This is selecting what item I'm working with at this point, and I just have the sprite one selected at this point. You can see that under scripts, there's nothing. There's absolutely nothing. So the sprite doesn't really do anything. To activate everything, you have to click the green flag, which is kind of like the green flag in a race. Okay, when you see someone waving the green flag, it's time to step on the gas and get going. So that's basically what it is. If you want your program to stop, you can also hit the stop sign. But that will basically stop the execution of your scripts. You can also control the layout of the screen. There are 3 ways to control the layout. This is good, if you want to maximize the screen and just really focus on, how the program works. The one that is in the middle, I like it the most. But if you want to put more, area into the workbench, this is how you can control and say, okay, I need more, area, more workspace for this particular program. I just use the middle one, for the most part, okay. But you can definitely, change it the way, to the way that you want it. All right. So let's go to, the really simple stuff and go to sound first, okay. Now, unlike Visual Basic, unlike particularly C and C++ or Java, those are all programming languages. Programming in Scratch is very interactive. In other words, you don't have to read, 70 pages just to say, oh, now I understand what this, command is going to do, okay? And then you have to read another, 70 pages to write a very simple program just to test one little thing. In Scratch, you just click something and it will do it, okay? It will demonstrate what that one little block is going to do. For instance, let me just click this one here. People in the back may have a hard time reading it because the font is kind of small. It says play sound, and then in the drop-down box, it specifies meow. Okay. So what do you think it's going to do? Exactly. Did someone do it, or was it from a computer? Okay. Okay. Because it. Did you hear that? Okay. Let me crank it up. Okay, it's kind of it's not as good as it sounds. It really should sound a lot better. Yep, go ahead.
Can you import sounds into Scratch?
Absolutely, it comes with a huge library of sounds already. Okay, so if you click it, just click the drop-down box, you can see a record button. In other words, if you have a microphone like what I have here that is already connected to it, you can record on the fly and say, okay, instead of the built-in male sound, you can say whatever you want to say, right? Well, I have never tried it when the recorder is already being used to do screen recording. I think it can do it. Let me give it a try here. No, it just crashed the software. It's okay. I can always just bring it back up. Okay, because I haven't really done anything yet.
So if you got sound already recorded on your computer, you can turn around and just put it on it.
Right. I just want to make sure I didn't break the sound recorder.
Can you
And
make the
that was the
character
recording.
move?
Sorry?
Do different things? Like, can you make the character move?
Oh yeah, absolutely. Okay, so I'm just trying to go through the simple stuff first, because some people can get hoped just for this really simple stuff. You can also play tones or play drums. Okay, so this one here, it says play drum 48, and that's basically what kind of drum, what kind of instrument. So 48 is right here. It's a high mid tom, okay, which is a kind of drum for 0.2 seconds of beats. Okay, and you can change that number here to 2. I think that means 2 seconds. You can also change to. I'm not a musician, so this is all kind of new to me. So we'll try another instrument, number 53. All right. So you can see right away, you can actually do kind of certain things about it. Okay, you can play. Okay, let's try play note here. Okay. So in this case, note is C is middle C is 60. How many people know how to read a keyboard, like a piano keyboard? Okay, so you can actually play the sound or select which note you want out of the keyboard. So you can basically go. How many people know how to read the A, B, C, D, E, F, G? Okay, well you can use that too. Okay, that's half a beat. You can set the instrument to something else. Okay, so you can set it to
Number 4.
Number 4, honky tonk.
I just gotta hear this.
Okay. Yeah, there's a beat to it. I think this has to do with the software that I'm using right now. Okay. Yep.
This is kind of confusing me because everything that you're doing right here and that's listed on the program,
right,
the same thing that I do on video editing to do whatever I want to do.
Well, we're slowly ensuring we're getting there. Okay, just be a little patient. We're getting there. Okay. All right. So this is basically what you can do with sounds, but you don't want to keep clicking things to make things happen on the screen, right? So one thing you can do is to start to write a script. Okay. The term script in a setting like this is truly like a script intended for an actor on the stage. Okay, it's basically instructions for a particular sprite or an actor, if you will, to follow when that actor is on the stage and the play has already started. Go ahead.
Are we gonna have to log into it, make a screen name and all that stuff for it? Is this something we need to show you, or?
When we get to that part of the assignment, yes, but at this point, I'm still just kind of talking about the concept. You don't need to have an account. You can turn in the file itself. In other words, you can just turn in your homework as individual files. Okay. All right. So the first thing we want to do is to say, well, I want the cat to do certain things. If I want to automate it. In other words, I want the cat to do certain things when I just run the program, because I don't want to have to keep hitting those different buttons and stuff like that. So I'm now switching to the script screen here. This is my workbench. My workbench is being used to specify a script. This block here, when the green flag is clicked, is basically a way to start the script running. And one single actor, unlike an actual actor, a single actor can follow multiple scripts at the same time. You can have one script that is only used to specify what audio stuff should be happening. You can have a separate script to basically specify how the cat should be walking around, and yet another one to do other things. Okay, so you can have as many scripts as you want per actor in this case, which can come in kind of handy and fun. All right, so we'll go ahead and click, just click meow here, and then we can go to control and stop this whole thing. And to stop the whole thing, you have to go to stop script. It's not really necessary, but I think it's always a good idea to indicate the beginning and also the end of a script. So now we can just go click the green button, the green flag. That's it. That's all this program is going to do at this point. Not very interesting, is it? Okay. Let's do something else then. Okay, because if it's not interesting, you can also click on the Sounds tab here in the Workbench. So when you click that, you can actually see that there are different options here. Now you can do the import. Okay, let me just go back one level. You click the Sounds tab on your Workbench, and you click Import. Now you have all kinds of options because it already comes with a lot of sampled sounds already. Okay, they're not really intended for musicians, or you're not going to make something that's really going to be very impressive in terms of sounds. But you can look under animals. They have different types of sounds for different animals, including crickets and stuff. You can go look at effects. There are these sounds already recorded. Human instruments, vocals, percussion. So they're all basically these are pre-recorded. If you don't like any one of these that is already pre-recorded, and you have something else that is also recorded, you can go to your own folder and look under your own folder to find something that you already have. Okay. So if you have Audacity, which is a sound editing software, or if you have certain tracks from a certain movie or music that you want to use, you can just go ahead and use that. Okay, so you have a lot of options here. All right. So that part is not too interesting to me. I want to see this cat move also. In addition to making that sound, I want to make it move too. Which tab do you think I should be looking under?
Motion.
If I wanted to move.
Motion.
Animation.
Motion. Well, there's no animation tab here, so motion is the right one. So I will look into this particular drawer, and these are all the motions that you can specify. I know people in the back may have problems reading this. This is move 10 steps, turn 15 degrees, turn 15 degrees. One is clockwise, the other one is counterclockwise. Point in a certain direction, point toward something. And if you click the drop-down box, right now there's only one thing that the sprite can point to, which is the mouse pointer. Okay, well that's pretty handy, because that means the cat can point toward the mouse. Okay, wherever the mouse is, it will point to the mouse. Now that's a really good, useful building block for a game. No, you guys are not. Okay, we'll talk about how to write a simple game using this kind of feature. You can go to a particular coordinate. Coordinates are specified using the XY coordinate system. So you can make the cat jump to a certain position if you want to. You can say glide to a certain position. In other words, it will just glide, at a slower pace, to a certain location. Change X by a certain amount, change Y by a certain amount. It is just changing one of the XY instead of going to a particular coordinate, which can change both coordinates. You can change one at a time. If on edge bounds, which means you automatically reverse the direction of the sprite when it is already at the edge of the stage. Okay, so we don't want to do anything that's complicated. I just want to see how it can move 10 steps. Now instead of writing a script that includes move 10 steps, I can just click that block and it will do it. So that makes testing very easy because you can just click it. So right here, I just click move 10 steps. Move. There you go. And you can click again, and you can see the cat is kind of moving, 10 pixels at a time. Yeah, that's kind of okay, but I want to see what else we can do with this. All right, so let's go ahead and write, another script here. Okay, you can write multiple scripts for the same sprite. So I'm going to use another script. This one is just going to move it, a few steps. So I just drag. Do you see how I just drag something out of the drawer and put it onto the bench? Okay, so I can just say move 10 steps, move 10 steps, move 10 steps, and one more time. And then I end this particular script. All right. So right now, this particular sprite, which I'm calling, the default name is Sprite 1, which is not very inspiring. But right now, this particular sprite or actor has two scripts to follow. And both will start when you click the green flag. One makes it, make a sound. The other one makes it go, basically 10 steps forward, but 4 times. Okay, so we'll take a look and see, how this is going to work out. Okay. All right, so we'll click the green flag. Okay, that's not very interesting. In fact, it doesn't do what it is supposed to, right? Because what it did was it's combining all the move 10 steps into one move 40 steps. Because those particular individual steps were right next to each other, So to our human eyes, we could not actually see it going 10 steps, each time, because there's no delay between the steps. So we cannot see it going like. Instead, it's like, one single step. It's 40 steps. Okay, maybe we should change the program a little bit to introduce a delay. A delay is under control because what you can do is you can specify wait a certain number of seconds. It doesn't have to be an integer. It can also be a fraction. I shouldn't say fraction, but it can be a decimal number. So you can say, okay, between moving 10 steps, let's space them out by 0.2 or 0.3 seconds, which is perceivable by human eyes already. So you can just drag it. Now this is the other part that's interesting. In a regular program, you will have to go to the right line, press the enter key to create an empty line so you can insert new statements. In this case, it's also drag and drop. Drag and drop. Okay, you can see, when I'm still holding down the mouse button here, but you can see that, over different areas, it will basically tell you, oh, do you want me to insert it here, here, or here, or here, or here? Okay, so this is truly drag and drop. Just, drag and drop. Okay, I can change the 1 second to 0.3 seconds. Okay, and I can change the other one to 0.3 seconds too. And you can also replicate. You can right-click on something and duplicate, that construct. But in this case, it's not duplicating just one single step. It's duplicating everything from that step and down, okay, which is not what I want. Well, since I still can make use of this one, so I can make duplicates of that one too, and only once. Things that you do not need anymore, you can sweep it out of the workbench just by moving those out of the workbench area. Then it will be lost forever. In other words, if I just drag it back to here, it's gone. Okay. So there's no trash can to get rid of something. You just get it out of the workbench and it's gone. Are we still doing okay so far with this program? Yep. Yep. We're getting there. I'm glad that you guys are thinking ahead of me, but we're getting there. Okay. So let's go ahead and run this program now and see how it works. Yeah. Okay, it's walking a little bit. It has a delay in between. What if I wanted to walk like 10 steps? Well, there are several ways to do it, right? I can duplicate the blocks, just repeat that process until I have 10 of the move 10 steps blocks, right? With the spacing in between, the waiting. But that's going to be quite boring, okay? Because and it makes the program really rigid too. Because what if I want to make it go 7 steps instead of 10 steps? I have to take out the 3 steps. Okay, now this is where programming can come in handy. Okay, so instead of specifying 10, move 10 steps and wait 0.3 seconds, what you can do is use what we call a loop. Go ahead.
I was just going to say, would you just loop the steps?
Yep, we can use a loop, which is a construct to make the script do certain things a certain number of times, or do it until a certain condition is either true or false. Okay. Do we use loops in daily life? Do you do things repetitively? Yep. Such as when you're doing your homework, right?
Yeah,
okay,
homework.
Let's say you're doing your calculus homework and there are 20 questions. Then you are actually doing something repetitively, okay? Pick up the next question, work on it. Am I done yet? No, because there are 9 more questions. Pick up the next one and so on, okay? So we'll go ahead and try something like that. So for something like that, if you want to do something a certain number of times, it is also under control because you are specifying the behavior of the program. And for people who are upfront, who can actually read the name of the blocks, which one do you think I should pick? I just wanted to go, perform the same thing 10 times. Repeat 10, right? Okay, because there are 2 repeats. The other one is not visible right now, so that's okay. So this is the block that I want. It says repeat 10, and it looks a little bit funky, okay? Because there's a little thing here that looks like an arrow pointing back up again, right about here. Let me see if I can find a magnifying tool for this. No, I don't have it installed. It's an accessibility thing, but I don't have it installed on this computer. So the little arrow that points back up basically says potentially we might go back to the beginning of this entire block and do everything from the beginning of the block again. Okay, and that's the basic construct of a loop. Is you can go back to an earlier step and do it all over again. Okay, in this case, to get out of the repetition is easy. We just want to perform that thing 10 times. That's all. Okay, so we'll just do it 10 times. Okay, now the question is, how do I change this program to integrate something like this? Well, the first thing is I will separate the blocks out, okay, just like that. Stick this one in, and then I just need one thing, okay, not this one, but this, okay. This I can toss away now. I just need to say, okay, move 10 steps, wait 0.3 seconds, and then move this entire block inside the repeat 10 block. So now we have a kind of more complicated program in a way, but in a way it is actually simpler than the one that we had before. Because using the approach that we were using before, if I want to change the number of times to take 10 steps forward, I would have to replicate the number of blocks, and it's really kind of tedious. This time it's easy. I just change that number of repeat block, and it will repeat that number of times. Are we still doing okay so far with this program? Okay, so let's go ahead and run this program right now and see what it does. Okay, well, we want to see whether it's doing what it is supposed to be doing. Okay, so we want to move the sprite all the way back to the left-hand side because it's going to move to the right-hand side. Okay, and then we wave the green flag, and it's going to go 10 steps forward. Okay, well, that's pretty good. That's useful. Okay, that's useful stuff. And then somebody mentioned that it's not walking. It seems like it's just limping forward because the leg is not doing that motion, right? If you want to change how a sprite looks, out of all the tabs or the drawers, which one do you think may be related to that?
Variable. Costumes.
Costumes. Yep. Well, costumes will give you, it will show you what costumes are available. Okay. So if you click costumes here, it tells you that we have 2 costumes already. You can see that the 2 costumes are really the same, almost exactly the same, except the hand and the leg and also the tail placement is a little bit off. So if you keep alternating between those 2, you will have a kind of walking motion. Okay. All right. So we want to integrate this into our script too. But that's kind of troublesome because we have to tell the script, go for costume 1, then costume 2, costume 1, and then costume 2. Well, that's actually an easier way to do it. In your drawers, remember this is your toolbox. Which drawer of the toolbox do you think has the stuff that we are looking for?
Operation.
Looks. Okay, a costume falls under looks. Okay. So we go back to scripts here because we are still trying to modify the script, but this time we want to kind of integrate the walking motion. So and then we look into the toolbox. You can see how I'm doing this. We switch the workbench to the logic part to specify the behavior of the program, and then we switch to a different drawer of the toolbox so that we can pull a different tool out of the toolbox and put it onto the workbench. Okay. So we want to say just next costume. That's all that we need to do. Because what it does is next costume will look at all the available costumes for a particular sprite, and it will just cycle through everything. Once you get to the last costume, it will go back to the very first one and repeat the whole thing again. So that's all we need because we have 2 costumes. We just want to alternate between the 2 costumes. Okay. So now we can test the program again. In fact, if you don't want to try out the entire program, you can just click next costume and find out what this little item is going to do. Just click it. There you go. So as you click it, you can see the sprite just changing a little bit, but since it's not moving horizontally, it doesn't look like it's moving. Well, we can call it Michael Jackson kind of moving. Moonwalk, right? You can actually program it to walk backwards with the forward motion of the walking. Then you can make this thing do the moonwalk. We can program that. We can do that later. Okay, so right now we just want to see whether we can make it appear to be walking forward. Yeah, it's kind of hopping around. I mean, okay. So do you want to make it do the moonwalk thing? It's easy now, okay? It's very easy to do the moonwalk because now I only have one place to modify, which is to change 10 steps to negative 10 steps. Right? Because positive 10 step is moving to the right-hand side, negative is going to make it go to the left-hand side. Okay? But because the cat, or the sprite, is still facing to the right-hand side, to make it step backwards will make it look like it is doing the moonwalk. Trademarked, right? TM. All right, so this time we want to drag it kind of over here and then test the program again. Yeah, the moonwalking cat. Now, if you have a CD, of Michael Jackson's music, now which one does it come from? The moonwalk thrillers?
I think Smooth Criminal.
Huh?
I think Smooth Criminal was the one where it was really
the
big.
album? Okay, but which
No, that
song?
was the song.
That was the song?
Yeah, that was the song. At least I think it was.
You know, it was a song.
Yeah.
Huh?
No.
Billie Jean.
Yeah, Billie Jean.
Now I want to find the answer. It's my ADD talking again.
Was it?
Yeah, I think it's Billie Jean. In fact, there's a Wikipedia entry just for that.
Actually, it refers to the movie.
Oh, yep, go ahead.
How do you pick different sprites?
Okay, well, that's a good question. So I'll put it on my, queue of ideas to talk about. Okay, so let's go back to this sprite first. Okay, so that's really kind of useful because I can now, do all of these things. Okay, next thing is, it's kind of boring if every single time you run this script, it will only repeat 10 times. Each step is 10 pixels, and the delay is only 0.3 seconds. It's all static, right? It's not changing. What if I want to experiment with this program and find out the best pacing and the best delay and stuff like that? I would have to go back and keep changing the program itself, which is kind of troublesome, okay? So what I want to do is to make the program interactive now. In other words, when the program runs, I wanted to ask the end user, how many pixels per step, how many times should I do it, and what is the delay? Are we doing okay so far with that concept? What I want to accomplish, not how to do it, just what. The what is okay? Okay, so now we want to take a look at how to do it. Okay, so we'll keep the scripts that we already have here. We'll modify that later. But what we also want to do is to specify or play around with something else that can make it interactive. Now this part here is a little bit tricky, so I'm not going to ask to see if you guys can find it. It's under sensing. Under sensing, there is a block that says ask blah 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 and wait. Okay, now that is useful. Okay, so we want to write another little script here just to test that feature. Okay. So we'll go ahead and write another script with another green flag here. And later on, we'll combine all of these into one single program. So we'll go ahead and drag this ask thing here. And then we'll also, let's see. And then we'll click this thing here, okay? There's a little check mark next to answer, which basically means if I check it here, whatever I type to answer this question will appear here. And that's all that I want to do right now, okay? And then that's the end of this part of the script. So I have 3 scripts for one single sprite at this point. The third one is somewhat trivial, but we want to find out what it does exactly. So now we run the program, it's still doing the moonwalk, but at the same time, it gives me a little prompt. Okay, do you see at the bottom of the stage, we have a little prompt, and I can type whatever I want over there. Okay, so I can type whatever. Okay. And then I can press the enter key or click the check mark here. And then you can see the answer has the whatever I just typed. Okay? Not very surprising, not very useful at this point either. Okay? But this gives me a mechanism to ask a user, how many pixels do you want each step to make? What is the delay between the steps? And also how many times I should repeat this. Right? It gives me the mechanism to do it. Okay, let's do that. So to do that, we just have to repeat this ASCII 3 times, so I can just use duplicate if I want to. And I have to change the questions, okay? Changing the question itself is easy. Instead of asking what's your name, I'm going to change to how many steps to perform. And then the next one is going to be how many pixels per step. And then the last one would be the delay. Delay between steps. Okay, there we go. All right. Are we still doing okay so far? This program is not really getting very interesting. It's just going to ask 3 questions. But we want to kind of focus on the answer thing at the upper left corner of the stage, okay? Because we want to see whether it can keep track of all 3 answers at the same time. So we're going to run the program again, and you will be distracted by the cat doing the moonwalk, but we'll just wait until it's done with the moonwalk first. Okay, so now we only have 1 script left. Okay, you can see that this script that is still active is still highlighted. The other 2 have stopped already, so they are not highlighted anymore. Okay, so we'll just do the same thing here. It's asking me how many steps to perform. Let's say 10 over here. And you can see 10 is the answer because that's exactly what I just typed. Now it's asking me the second question, how many pixels per step? Let's say we want to make it, each step is only 5 pixels instead of 10. So I'm going to type 5 and then press the enter key. What just happened to the answer? What happened to the 10?
It was overwritten.
It's overwritten. Very good. Okay, that's the exact word to describe it. The answer can only remember the answer to the very last question that you answer. Okay, if you had any other content before that, it's going to be lost. Okay, it seems like we have a little bit of a problem here, because to answer the third question, delay between steps, which is the number of seconds, which is 0.2, now I have lost the number of pixels per step, which was 5. Okay, so it seems like we have a little bit of an issue here because we cannot remember the answer, of all of the questions. We can only remember the answer to the very last question asked. Okay. So now we have to rely on yet another concept so that we can keep track of all of these things, even though the answer keeps on changing. We want to take a little snapshot, of or a copy of each answer whenever we have the answer to that question. There was a question? No? Okay. And that concept is, okay, can anyone guess? Some of you already know enough about programming. Go ahead.
Variables?
Variables, exactly. So variables are very useful concepts because each variable is a thing. You can look at it as a little post-it, okay? It can store a particular value. And you can create as many variables as you need in a script. In other words, you can create all these little post-its, okay? Each one has a name, so instead of saying, that post-it and the other post-it, you can name the post-it and say, I want this post-it, that post-it, and that post-it, using the name to identify it. And then I can use variables to remember the answers to the different questions. Okay, does everybody understand the rationale or what I'm trying to do? Okay, so we'll go ahead and try to do that. Make a variable. Click make a variable. It will ask you about the variable name. There's only one rule that you have to follow in this case. All variables must have unique names. In other words, you cannot name 2 variables the same, because then the program cannot identify which one do you really want to refer to when you want to make use of the variable. Okay, so in this case, I will name the variables pretty much the same thing. Make the variable names describe what it is storing. Okay, so we'll just say number of steps. You can actually use space in this case. You can actually say number of steps using the space as a part of the name. This is okay with Scratch, but with most other programming languages, you cannot use a space as a part of a variable name. But in this case, I'll use a space because it just makes it so much easier to read. You also have an option of, do you want this variable to be available to everything, okay, all the sprites, or just for this particular sprite? Well, we just want it for this particular sprite, so you click this option here, and then you click OK. Now let's take a look at this area here into the toolbox. Whoops! It just pops up all the other things. Okay. We'll talk about the other things later on because they're all useful. And then we'll create two other variables. Okay. The next one is going to be the number of pixels per step. So we'll just name the variable accordingly. Pixels per step. Click OK, and then yep, there you go. And then we'll make yet the last one, which is the delay. Okay, so this one is delay between steps, and we'll make it only available for only this sprite. Click OK. So now we have 3 variables. By default, they have a little check mark next to it already checked, which means they are displayed here on the screen. When you're debugging a program, that's a great idea because it really shows you how the values of the variables are changing. So that's a good idea when you're debugging a program, but when you're running the program or when you're distributing the program when you're done, you can just uncheck all of these things so they don't really show up on the stage to kind of distract the end user. Okay, are we still doing okay so far with the program? Okay, so we got variables, we got questions, so now let's run the program again because it seems like we have solved the problem. Okay, let's do it again. I think that part is really good for waking up people who are just falling asleep because I don't. All right, so now we just answer the questions again. 10 steps to perform per step. Hey, okay, the answer is changed to 10, but the number of steps is not affected here. What about the next question? How many steps? How many pixels per step? 5 pixels per step. Press the Enter key. Oh, we're not relating the answer to the questions to the variables that we have just created. So even though the variables are there, there's no connection between the variables to the answers of the questions. Okay, so we still have a little problem here.
You have to assign it though.
Correct. We have to make a copy, right? We have to copy the value of the answer to the variables. Okay. So which item in the toolbox should I use? Should I use set, change, show, or hide? Take a look. Well, the show and the hide is pretty obvious. Between set and change, I should use set because change, you cannot really see this part here, is changed by a certain amount. In other words, are you increasing it or decreasing it by a certain amount? That's not what we want to do. We want to just make a copy. Okay. So we want to say set over here. So we just drag set after the ask and do it 3 times because we need 1 for each answer. This is not going to do it right either, right? Because at this point it simply says set delay between steps to 0. We don't want it to be, but first of all, this is not the variable that we want to set. Which variable do we want to set at this point of the program? These are my choices. Which question did I just ask?
Pixels per step.
We just no. We just asked
Delay between steps.
Number of steps. We just asked how many steps to perform. So which variable do you think I want to change? Number of steps, exactly, which is the second item. Okay, well that's easy enough because the drop-down box let me select which variable. Do I want to change it to 0? No, we don't want to change it to 0. We want to change it to whatever the answer was, right? When the user types something and press the Enter key, that becomes the quote-unquote answer. So we want to set this variable to the same as quote-unquote the answer. The answer is under sensing. And this is the other part that's really cool about Scratch programming, is if you want this 0 to become answer, you just go to answer, you just drag it, drop it over here, we're done. Okay, do we have any questions at this point? Yep, go ahead.
What would you do if what's the best way to get to halt the thing if you gave a wrong answer? How would you do that?
Well, first of all, you have to detect, well, first of all, you have to find a way to find out that you have, quote-unquote, a wrong answer. And then you can use the concept of a loop to go back to an earlier step to ask the question again.
Okay.
Yep. So that's how you can do that. All right. So at this point, we have, this step here. I'm not going to change the other ones until I know this one is working, all right? So we'll go ahead and run the program from all the way from the beginning again. The cat is still doing his moonwalk. And this time, I'm going to specify 10 steps to perform. Press 10, and then press the Enter key. Ah, the program is working fine now because you can see that I just typed 10 and I just typed in 10 and press the Enter key. So the answer is 10, which is good. But at the same time, I can also see that number of steps is now changed to 10. So I know the approach is now working. I can set variables to the answer of a question. Now, we are already talking about stuff that you cannot do with what you just mentioned, the movie editing kind of software.
Okay, the other question is, how can you change the picture? If you want to change the picture to do a program, how would you change that?
Yep, we'll get to that part, okay? Remember, this is all kind of impromptu. I'm doing this, because I just found that, hey, you guys are all interested in this. Let's do this first. Okay.
Because like I said, so far what you've been showing is basically still dealing with, depending on what type of video software you're using.
Well, this is not video. Okay, let me stop.
But
Yep,
like
go
I say,
ahead.
it's a program.
Okay, so the next one is going to be number of pixels per step, which is pixels per step. And then we want to change that to the answer as well, because there's only one answer. So this one has to be changed to answer. And then the last one is going to be the delay between steps. And once again, we want to go to answer and put it here. Are we still doing okay so far with this program? Okay. So this time, let me just go ahead and run the program again. And it's moonwalking behind the stage now. Okay, but our attention is really to, can we remember all those numbers, all those answers to the questions? Okay, 10 steps, 5 pixels per step, and let's say 0.2 seconds between the steps. Oh, cool, right? We can now remember all of those items. But the program or the sprite is still only performing 10 steps, 10 pixels per step, and a delay of 0.3 seconds. Why? Because this part of the program is not utilizing the variables. Is that making any sense? Okay. So that means, we have to change the program because we want to ask the questions first, right? And then we'll have the sprite to do things according to the specification that we have just specified answering the question. Does that make sense? So the ordering is now important. Well, as it turns out, it's not really too hard to do that. We just toss away this little end here. We toss away this beginning here. And then what we need to do is to change the ordering by moving this chunk first. Okay, so we'll have to ask all the questions first, but don't stop at that point, because after we answer the last question, we have to perform the actual operation. But according to this, it is still going to repeat exactly 10 times and moving negative 10 steps per step, and wait only 0.3 seconds between the steps. What do I need to do now with this program? I'll give you a hint. Utilize the variables, right? The variables that we have changed earlier. It is time now to utilize the variables. So instead of just saying out, spelling out 10 times, you know what? I don't want to use exactly 10 times. I'm going to specify the number of times to perform these steps using this variable. Is that okay? Because this is really a useful concept. It's a jump from using a constant, now we're using a variable. And instead of moving exactly negative 10 steps, we'll just say, whatever number we specify as the number of pixels per step, use it over here. And then for the delay, it's the same thing. Use the variable delay between steps and stash it over here. So now we have a far more flexible program because it allows the user to specify those numbers and then use those values when we actually perform the steps. Okay. So let's go ahead and see if this program works. Okay, click the green flag and drag the cat to the middle here because it's already walking behind the stage. Okay, how many steps to perform? Let's say 20 steps. Okay, because we want to pretend that Scratch is wearing kimono, so he can take tiny little steps. So we'll have a lot of little steps, 20 steps. And then each step is going to be very small because wearing kimono is not very convenient for walking. So 3 pixels per step, and we want the delay to be kind of short because taking little steps don't take a lot of time. So we only need 0.1 second between steps. Okay, now as soon as I press the enter key, it will get to the second part of the program to actually perform the steps. There we go. All right, so now to answer your question, oh, she left already. Which is, how do we specify more sprites or to specify or to add more costumes or to change costumes? This is how you do it. To create another sprite, you use one of these 3 buttons. Okay, so I'll just hover over. You can create a new sprite by painting it. In other words, you're creating a sprite from scratch. Okay, you just start with your own, drawing, canvas, and you just draw whatever you want. The second one is to choose a new sprite from file, which means okay, I can click this. It has all these sprites already created inside Scratch. It is already in the distribution. As soon as you install Scratch, you have all of these available to you. So you have, we can just look under fantasy, okay? So you got dragon, you get all kinds of ghosts, ghoul, and dragon. Oh, okay, I just looked at that. Knight, jumping jack, robot, skull, sun, whatever. So you can create something out of whatever is already available to you. And this one is to get surprise sprite. It's kind of like you just click it and it just randomly pick one. I think this is a pair of glasses or something. What if you don't like it? What if you don't need a particular sprite? How do you get rid of a sprite? Right click and delete it. Okay. Now, if you want to add costumes or change existing costumes, like in this case, what if I want to make Scratch or the cat looks like he's or she is wearing kimono? Well, what you do is you click the Costumes tab on your Workbench, and then you click Edit. Now it is kind of like Paint the software. You can change it pixel by pixel. Okay, so that you can make it look like it's wearing kimono or whatever you want. Okay, it takes a lot of time to do all the editing. Some people have they have the talent to make things look really really good. But that's how you do it. You have all the basic tools. You have a pen tool, and you can select from these colors. You have an eraser tool, a fill tool, paint fill tool. You can draw rectangles and circles, straight lines. You can even use text if you want to. Selection tool. This one is a what? It's a stamp, and you can select an area. Okay, so you can make replications. Okay, duplicate something, and this is an eyedropper, so you can actually look at the color at a certain place, so you can replicate the color of a pixel to the rest of the picture. Are we still doing okay so far? Okay. Yeah, so you can edit whatever is available, and if you want to create a new costume, you can do that by painting too. So you can actually paint a new. You can make a copy out of an existing one, or you can use Paint, Import, or Camera if you want to create a new costume. In other words, if you want to make a shooting game, where your face is the target, okay, and you want the face expression to change, as you're getting hit by paintballs or whatever, then you can take a picture of yourself, trying to taunt, the user to shoot you, is like that, and and when you get shot, you can go like, do something like that, and you can do it all from your webcam. Okay, if you have a laptop computer, just turn on the webcam and use this feature. Click camera, and then you can use a camera to capture all that stuff. In other words, you can put something together really really quickly. Now, if you want a shooting game, and you're using yourself, as the target, you can also use sounds here. Instead of using the meow sound or anything that is built into it, you can use the recorder feature. Okay, so you can click record to create a new sound. So you can basically just use your webcam or your microphone on a laptop computer and just say ouch, okay, and then that becomes available to you as a sound to play when you specify the rest of the program. So you can kind of see how this can be a lot of fun because it doesn't take a lot of work to create the program and also put in the multimedia content into the program. Okay? And you can look at this and go like, yeah, this is all kind of fun, but is it really useful? Can I really do this? You use it for any real purpose? I can point out two things. Yeah, three things. Okay, one is Android programming. How many people have kind of thought of, I wish I could program my cell phone and write an app for it to do certain things? Okay. MIT has another program called App. I think it's App Creator or App Designer. It uses the same type of interface, drag and drop programming, and the same thing with the multimedia stuff. You can record your own sound, import stuff and whatnot. But the only difference is it runs on an Android device.
What's it called again?
I think it's called App Designer or App Creator. I cannot remember exactly.
Through the same company, like the MIT.
It's called App Inventor. Okay, so it was neither of the ones that I chose, but it was created. App something from MIT. So it was actually App Inventor. Okay, and this one allows you to create an app on a computer and be able to install it on an Android phone or tablet. Okay, it's a little bit more advanced. Okay, the stuff that we talked about today is the foundation, but this one is actually a little bit more complicated. So that's one practical use of Scratch. Okay, it's a really good training platform to actually write something that can be uploaded to a phone. That's number one. The second one was something that we saw a little bit earlier, which is using Scratch in the case of Raspberry Pi. All right, Raspberry Pi, I think we might have talked about this a little bit. Yes, no? Nope. Oh, okay. That's something that we really have to talk about.
Minecraft.
Okay, a Raspberry Pi is a device about yay big. Okay, it's kind of small, but I wouldn't say it's like tiny, but it's small. It can run on battery, but the thing about it is you can run a full version of Linux on it. Okay, so it's fairly powerful for the size and the power consumption. It's actually quite capable, and it can be programmed using Scratch. So now you can have a little thing about yay big. It has what we call GPIO or general purpose input output. We talked about input output for a regular computer. This one is a little bit different. The input output is designed to control other stuff. If you're experienced and know what you're doing, you can use Raspberry Pi to control a robot. Okay, so you can control motors. You can use it to sense stuff and whatnot. There's a certain limit of what you can do and what you cannot do with it, but it's quite capable. Okay, it's designed for embedded applications, for controlling robots, UAVs, stuff like that. So now you can program a robot or a UAV using the same engine as Scratch, which I think is kind of interesting. Okay, it really is programming for the masses. Okay. Yep.
You said that we can use that for robots?
Potentially, yes.
So that means that if I design a robot and I make a program, I design.
Yeah, the Raspberry Pi is.
A CD, and I make my program and I plug in the CD.
Right.
Using the computer.
It is still actively being developed, so it's not quote unquote done yet, but I think people are actively looking into, using Scratch to program Raspberry Pi, and then there are robotic projects in Raspberry Pi they can look into as well. All right.
Well, this freaking thing was getting good. People go.